Hey, hello there, and welcome back for more Advent of Code. So today is day 3 of Advent of Code, and let's try to keep up with the puzzles. So let's go to adventofcode.com and day 3. Let's see what this is about. Gear ratios. Okay. Already it seems like it's a grid puzzle, so that's nice. I usually like those. So, what's the story about? You and the elf eventually reach to a gondola lift station. Gondola lift is those, this kind of chair lifts that are covered sort of in ski resorts or things like that. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They are not moving. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that the engine part seems to be missing. That an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. All the part numbers in the engine schematic. Okay. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number. Okay, and should be included in your sum. Periods do not count as a symbol. Here is an example of engine schematic. So okay, I guess these symbols are engine parts, or what? Any number adjacent to a symbol. Okay. So adjacent to this symbol, I guess it's 7, 3, 5, and so on. In this schematic, two numbers are not part numbers because they are not adjacent to a symbol. 114. Okay, so numbers are like whole numbers, like with multiple digits, I guess. And this one doesn't touch any weird symbol, and I guess 58 doesn't either. Every other number is adjacent to a symbol and so is a part number. Their sum is 4,000 and something. Of course, the actual engine schematic is much larger. What is the sum of all the part numbers in the engine schematic? See the input, I guess it looks the same but bigger, yeah. Okay. So this is, I guess, technically a grid puzzle, but it's not really a grid puzzle that's of the kinds that I'm used to, where you like move around and see things. Although we will need to do some like neighbor detection. So yeah, I guess it does count as a grid puzzle. Okay, so let's open a terminal and jump into this. Open the text editor. Increase the font size. Okay. No, actually I didn't want to close that because I need to copy the templates. And the name of the puzzle today was gear ratios, but the description doesn't talk about gears at all. That's weird. I wonder if ratios. I wonder if part 2 is about gears or something like that. Also, I'm curious about these symbols. And how do they look on the actual inputs? Yeah, there are some equal signs. Okay, they seem to be like ASCII symbols, but I don't see anything suspicious about them. Okay. And let's also copy the template input folder. So the actual input is going to be this. Let's copy it and put it here. Yeah, sure. The sample should be this. And the output for the first part at least should be this. Okay. And let's close everything else. And let's think, what should we do? So one of the tricky things is that we need to not think about individual digits, but about whole numbers. I'm wondering, how are we going to do that? I guess we can try out for part one to do a very straightforward imperative solution of going, through each line. That would be each y coordinate and then each x coordinate, scanning this thing. And when we find a number, well, we read until that number ends. We know how many characters that number has, and then check all the neighbors around it. Something like that could work. Yeah, and try to get an answer for part one, because I have no idea what part two is about, and I guess that's the kind of the fun about Advent of Code is that you don't know what's coming on part two. And well, I like to not do part one and part two as independent things. I like to then refactor things to get something cohesive and nice that solves both things. So yeah, that usually means that part one gets refactored a little bit afterwards. But yeah, let's. I think going for that seems like a sensible thing to do. And we are also going to need to put this thing into some sort of grid. So yeah, here we are reading the input. Let's do something like, let engine grid be input lines, and I guess we can just keep the lines, right? Yeah, probably. So this should be a vector of string slices. Yeah. I'm wondering also if it makes sense to have a vector of string slices or just do a vector of bytes, because this is all ASCII. Usually Advent of Code is always ASCII. And yeah, the good thing about working with ASCII, like bytes, is that you can do direct access easily, while strings don't like having direct indexing, but you can always get the underlying bytes of a string, so that's not much of a problem. But if you use bytes directly, then you have the problem of parsing those bytes. Is treating them as text is usually cumbersome, and in this case we need to parse these numbers, and ask if each position is like, if it is a digit, well, which I guess is not really difficult. Well, let's just try this and see how it looks, and maybe if it then makes sense to convert it into to work with bytes. So we're gonna have a mutable variable for the sum. Let's just call it sum, and let's start going like, okay, for y in 0, we can probably enumerate this, so say y and line in engine grid iter enumerate, something like that. Yeah, and then for the x, we cannot do like a for loop, because when we find a number, we are going to skip ahead until the end. So I think I need to use an ugly old school while loop. So while x is less than line length, it's gonna be nice. Let mutable x start at 0. And what do we want to do here? Well, we're gonna increment x, that's for sure. We can say something like, well, if and here's where I want to have maybe bytes indexing. Okay, so yeah, let's say let's bytes is line. What's the difference between bytes and as bytes? I think as bytes is what I want, because the other one is an iterator. If bytes at x. Oh, look at that. That's cute, right? This is U8, but there are some methods for ASCII. Huh. Do I have? Yeah, it's ASCII digit. This is what I want. That's good. If it is an ASCII digit, then we are in a number case. And what do we want to do in here? I guess this is the else case. We want to just increment and keep going. But if it is an ASCII digit, what I want to do is probably first measure the number, like how long it is, and then check all the neighbors, because yeah, one idea could be, let's take a look at the sample. Of course, we're going to need to worry about numbers that are on the edges, because not accessing out of bounds things. That's usually annoying. But yeah, for example, for this 633, once we read the last 3 and say, okay, this is like 3, has a length of 3, we could try to get this string and this string and this string and ask if any of those has like a special symbol, one of these. So that means something that is not a number and not a dot. And if it is, then this is like if any of those 3 lines, 3 slices, I guess, has one of those symbols, then it means that this is a part number. And by the way, does that mean that, like on the puzzle, like, you know, on the story, that means that this is like an engine part and this is its number, or maybe this one? Yeah, and this is the number that corresponds to this part, and yeah, it could be. But this number doesn't correspond to anything, so maybe, I don't know. I don't know. And yeah, some of the parts or symbols have multiple numbers around them. Yeah. Yeah, that means that I don't know if there are numbers that have multiple symbols around them. I don't see any on this sample, but maybe on the actual input there are. Let's take a look. Input for day 3, and it's giants. So yeah, it's a lot of text to look at. But what did I want to know? If there are numbers that have multiple symbols around them. It doesn't look like on a, you know, skimming through it. Like, it seems like every number has at most one symbol as a neighbor. But I don't know why that would be important. Well, if that is the case, maybe we could go the other way around and look, instead of looking for numbers, we can iterate the whole grid looking for these special symbols and then find all the numbers around them. And we know that those are going to be these special numbers. That's also another approach. And in that case, we will have to filter out the numbers that are not part numbers, because, well, we won't find them if we just look at the things that are around the special symbol. So that's also possible. But let's see. Okay, this is like we found a number. Then I guess I want to measure this number. So what I'm going to do is, again, not think about it too much and just have a mutable length. Let's call it num length, which is going to be 0. No, we know that it's at least 1, and we are going to do what? While x plus num length is less than line length, okay, let's do num, what do you want to do? Well, we're going to increase this thing, and we want to break if the thing is not a number, right? So if bytes at x plus num length digit, if it's not an ASCII digit, then we reach the end of the number and we break. Okay? Otherwise we keep going, incrementing its length until we reach the ends of the line also, because it might be to the left, to the right of it. And I think that's it. We know the length of the number. So let's check this and maybe print this thing. print line found a number at x equal x, y equal y, and the number is going to be what? Let's do this and let number be, well, we can slice the string. We can say string from x to x plus num length, and the number is going to be that. And then when we have found the number, we can skip ahead on the x and add num length to it. Okay? Does that make sense? I hope so. Instead of using num length, we can also have the x coordinate where the number ends, but yeah, let's have the length for now. And let's see how this runs. So cargo run, binary would be day 3 this time, and let's put it the input for, no, the sample input. Yes, sample txt, and we have an error which I haven't seen. This number cannot be known. Oh yeah, we're slicing, we need to take a slice. Okay. Yeah, okay, we found numbers and they look like numbers. That's great. So we found that one at 0, 0, 4, 6, 7. Yes. And the last one that we found is at x5. Yes. And y9. Okay. Yeah, this looks like it worked. Nice. So we found the numbers. That's great. We know how to ask if these numbers are part numbers, and that means if all the neighbors are not a special thing. No, if some, how do we ask this? If some of its neighbors, if any of its neighbors cells has one of these symbols, weird symbols, then it is a part number. Okay? So how do we do that? I would do something like, well, we have this, actually this is not the number, it's the num slice, let's call it. What do we want to do with this? Let's see. Do I do another stupid for loop here, like more nested loops? Maybe yes. Or maybe I want to extract a function like neighbors, and yeah, probably. So what are we going to say? Okay, let is part number. So it's gonna be a part number if what? If any. So we are going to get neighbors for each cell. So we can like go, for instance here, get all the neighbors of 4, all the neighbors of the 6, all the neighbors of 7. Because that's the same thing as going like calculating like the bounding box of it, but I think it's simpler to think about. So we're going to go from x to x plus num length. Yeah. And we're gonna map these to the neighbors. map this x to neighbors, and we are going to extract it into a function. Okay. Now, what do I want to say? If any of this has a special symbol, then we are a part number. Yes. And we are going to ask that, asking if any of the neighbors, so let's say that neighbors is going to be an iterator. An iterator that will give me a neighbor x and a neighbor y. So if any of the neighbors is a special symbol, and that means that it's not a digit, not a number, I think. So okay, that's a kind of a mouthful. We can access this like this, yeah, but you know what? Maybe I want to have a little function to access any xy coordinates. So can we just have it like a closure here? Let add be just a closure that will take an x and y of u size and u size probably, and it will give us the engine grid at y, and then this is a string, so we need to do as bytes, and then do x. Do you like this? Yeah, it likes it. And we can, well, this is not necessary, but we can say add x and y. Get rid of these bytes. And here I'm gonna say add this x and y. Okay, and here we want to say, this is kind of a mouthful, let's give some space. So if the neighbor cell, so nx and ny, is ASCII digit, so what do we want? That is not an ASCII digit and not a dot. So not an ASCII digit, and well, we can cut it again, nx and y, not a dot, so not this byte. Does that make sense? I think it does. So it is a part number if any of this, any of the digits of the number has a neighbor that is not a number and not a dot. Yeah, so it's a special symbol. Yeah, I think that sort of makes sense. Now we need to generate a neighbor function. So no, actually neighbors should take x, y, and the grid, I guess. engine grids. So yes, help me out again, Rust Analyzer. Yeah. Yeah, instead of taking a vector, we can take slice, and we can pass it, yeah, as a reference. And this should return an impl iterator of item tuples, right? Tuples of usize and usize. And you don't like this because sorry, I added a extra parenthesis. What am I missing here? Rust return generic impl. Do I want an iterator or into iterator? I don't know. Iterator. Yeah, I think that's what I want, right? Do I need to have like a lifetime annotation here? I don't understand this error. Let me do hack here. Just put anything and just return I don't know, engine grid iterator, and things will not match. And can't you oh yeah, it puts the specific thing. I don't remember how to do this. Yeah, it should be item. If I say something else like item U8, are you happy about that? No, you still don't like it because oh no, now it actually worked. Yeah, if we say that the item here is this, missing lifetime specifiers, great. Return impl iterator. Come on, blog post. No, what I want is impl. Oh, this lifetime thing that I don't understand what the fuck it is. Would you be happy with this? No. But if I tell you, like, okay, let's go to our original idea and say, what if I here return just this into iterator. Do you like this? This function returns a type that contains borrow value of the signature. Sorry, I cannot read the whole thing because of my face here. Okay. So we have to put lifetime annotations on this. I don't really understand why. But it's happy if I do that, which is weird. Does it need all of these things? No, it doesn't. Okay, I'm not really understanding this lifetime thingy, but let's continue on. So, what do we want to do for the neighbors? We want to well, do the usual neighbors code, which will be having like x plus 1. Like, okay, now let's try to go like in a circle. So the first one will be y minus 1, x minus 1. Sorry, this should be a tuple. Then it's going to be y minus 1 x, then y minus 1 x plus 1. Then it's going to be y x minus 1, then y x, then y plus 1. Then now yx is not a neighbor, that is the actual guy. Then yeah, this, then y plus 1, x minus 1, then x plus 1. Okay, and I'm not checking for overflows or underflows, which is not what we want. So what I'm gonna do is a little trick here and say let xy is gonna be, and let's use some signed maybe I can use esize. Yeah, why not? Yeah. So we're gonna use signed integers here, and then for each of these, well, we're gonna into iterate them, and we're going to filter the ones that are outside of bounds. Right? So we can use filter map, or what do we want to use? I think we want to first filter. So we're gonna have x and y again here. We are shadowing variables like crazy. And we can say engine grid get Okay. If it's negative, we know that we cannot get it. Okay, but maybe we can convert it, right? If we, like, this is a specified thing. If we do get y as u size, sorry, if y is negative, then when we do as u size, it's going to be interpreted as a giant number, I think, and this will be out of bounds. So this will give us none, and if y is positive, but is beyond the grid, it's also going to give us none. So this is what we want. So I guess what we are doing here is, well, and then, does this make sense? We could probably put a simpler predicate here. Yeah, I sort of want to say something like, if y is greater or equal to 0 and y is less than grid length, why don't you like about this? Well, this is intuitor. Shouldn't you give me, oops, well, we can dereference here. And x is greater than 0 and x is less than engine grid. Well, we know that y here is in bounds because we have already checked it, so we can say y as u size length. Yeah, this is a long check, but if all of this, and I realize that the font size is too small, if all of this is the case, then we can say, okay, this is gonna be sum x as u size and y as u size, else none. Okay, and yeah, I meant this to be a filter map. And smash this. And now all of this is a problem because now it does want to have the lifetime annotation here, and with that it seems to stop complaining. Okay, yes, because this iterator that gets returned has to live as long as this grid, or like, yeah, it's bound to the lifetime of this grid. That does make sense, yes. Okay, this is a horrible check, and I'm sure that there are better ways of doing this, but yeah, let's assume that that is fine. So now that we have this is part number, let's print out this println number num slice is part number, and let's print that is part number boolean. So we have a bunch of, no, we have some falses and we have some trues and falses, and so what's going on here? It seems like these false values are the things that are on the edge, right? No. But we did get a mix of trues and false, so that is something. Let's maybe, what do we want to do here? Does this logic make sense? If any of the neighbors, no, if any of this has a neighbor that is a special symbol, then we already know there is a part number. So we are asking that, getting the neighbors and asking if any is not a digit and this thing. So okay, the first one should be a part number, but it's not. So what did go wrong there? Let's print maybe the neighbors of these 4. Yeah, let's do that. So we have the grid, and let's just print ln 0, 0 neighbors are, and let's debug print neighbors of 0, 0 engine grid and collect into a vector. And let's run it like this. Okay, so the neighbors seem fine because it did filter, like 4 only has these 3 neighbors, so the filtering seems fine. Let's actually check also, let's remove this, the neighbors of, so this is x and y, right? X, y, are we passing the correct, where are we calling neighbors here? Here, we are passing x, y. Sure, yeah. And what happens if we say x1 and y0? That should have 5 neighbors, right? 1, 2, 3, 4, 5, yes. And if we pass 1, 1, it should have 8 neighbors. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It does seem fine, like the neighbors calculation. So then for this 4 thingy, I want to see, like the first one is going to be the neighbors for 4. This one should be an ASCII digit. So okay, 4 should fail. Let's print that maybe here. So we are going to do this for the first number. Yeah, it's gonna be a lot of print debugging here. Let's close this thing. And let's say let's sys symbol. If this is the case, then, well, we're going to return this thing. Let's print ln. So number at x y sys symbol. You don't like this because of that. Okay, number at 0, 0 doesn't seem a symbol, but number at 2, 0 should see a symbol, right? This thing, this 7, should see a symbol. So it should say that any so this symbol here is not an ASCII digit, and it's not this. So why is this the case? So let's grab this what do I want to do? Yeah, this is at y1 and x3. So can we ask this? Let's grab this condition. And print, maybe print line. What do we want? Let nx and y. So we said x3 and y0, and I don't know what I'm doing here. I know that there is a debug macro. So wait, here it said true, so it's not an ASCII digit and it's not this. Whereas if I ask, for instance, this on 0, y0, it should say false, I think, right? Yeah. So that is true, at least for that. So any should say true on here. So it's weird. So that's weird. Let's print more stuff. Because printing is the only thing that I know. Should learn to use an actual debugger at some point, but for now let's keep with this. I want to say something like give me the neighbors, and maybe let's do this. Let's yeah, let's print let's actually collect all of these things. Let's just copy something. Let's collect neighbors. We're gonna keep the neighbors. We're gonna do map and we are going to have an x and y and this boolean that we had, and then we are going to collect these things into a vector of stuff, and then we are going to see a number at xy neighbors, and we're going to debug print this thing. Okay? Yes, it's gonna be noisy, but we mostly care about the first one. So the number at 0, 0 doesn't see anything. False, false, false. But then, yeah, we said that oh, 1, 3, but we said 3, 1. I flipped something around, I think, and that was really stupid. Am I treating x and y's neighbors at x, y, nx, and ny? But here we are going up to, this is weird, or is it correct? No, I think there's an error here. So the neighbors of 2, 0 are 0, 1, 0, 3, that makes sense. No, wait. No, that doesn't make sense. This is y coordinates, right? Yeah. Something got flipped here. So, am I? Oh, yes. I'm flipping things on the neighbors. That's stupid. Okay. Damn it. Okay. So how do we flip this over? Let's do this. Grab the commas. Let's grab this thing and put it before. Then here, just going to say, well, this and y, and finally now this. Okay, not very pretty. We can think about that later, but yeah, it's x and y's here. I guess I could also have flipped the parameters here, but okay. Okay, now let's run this again, not think too much. Now we have a true here, and this is a part number. Great, 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 great. Let's comment this out, do less printing, and now we have only two things that are not part numbers, and it's the ones that, yeah, that the solution said that shouldn't be. Okay, so the logic here was okay, was right, but the neighbors function was returning flipped xy coordinates. So this is fine, we can inline this variable, great, and now we still have the same things, and now we can say if this is a part number, gonna increase the sum by well, this number, but num slice, we are not using this for anything, so we can just grab this and say parse, and if this fails, Well, we can propagate it up, I guess. That's one of the advantages of having this inside of a nested, super nested loop. Yeah, okay. But sum is... Well, it can be sum. What is the mismatch type? Why are you complaining here? Maybe I should extract this into a variable. No. Well, let's do num slice. Parse. Don't you like this? No. What is going on? I'm not understanding this. Let's say number is this. Let number be this. You know, like parse. Yeah, I'm really not understanding here what's going on. Not implemented for void, but why is this thing void? Why are you oh, do I need just a type annotation here? So this, oh, okay, that was stupid, but okay, and then we can do sum plus equal num. Sure, and then we can print the sum. Okay, are you happy with this? Is this the answer that we are expecting? 4361. Yeah, okay. So now let's run this thing with the actual input. And it's this big number. Let's see. Yes, okay. We did it correctly with some pretty ugly code, but it works. So let's continue to part 2. And I'm running out of mate. Maybe that's a signal that I should stop this video. Let's read what part 2 is about and then we decide. So, part 2. The engineer finds the missing part and installs it in the engine. I don't know how it did that, how he did that, but okay. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast though. Maybe something is still wrong. Fortunately, the gondola has a phone labeled help, so you pick it up and the engineer answers. Before you can explain the situation, she suggests, sorry, I said he for the engineering, that was bad on my part, I should have said them. She suggests that you look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. Okay. Its gear ratio is the result of multiplying those 2 numbers together. This time you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. Consider the same engine schematic again, this thing. In this schematic there are two gears. The first is the top left. It has the numbers 4, 6, 7 and 35. Yes, okay, this thing has these two neighboring numbers. Great. So its gear ratio is this thing. The second gear is the lower right, so this, and it has these numbers. The I don't know how to call it. This star adjacent to 617 is not a gear yet because it doesn't neighbor two numbers. Adding up all of the gear ratios produces this thing. What is the sum of all the gear ratios in your engine schematic? Okay, so now we have to go sort of the other way around. We have to find gears and the numbers corresponding to those gears. Okay. So, do we do another nested loops? I guess so, we could do that, but we'll have to repeat a lot of like this number finding logic. So I wonder if there is another way of doing this. So yeah, for a single gear, how do we know if a star is a gear? Well, we have to count how many numbers it neighbors with. But our concept of neighbors doesn't really help us here, I think, because those are like single digits. So we will need to find like whole number neighbors in some way. So, I'm thinking if it makes sense to do something quite different here. Like do a better parsing in the beginning, figuring out which are the numbers, and maybe having an actual grid with that information, and then do both calculations like in a better way, maybe. Yeah, that could be one way to go. We could also I'm trying to think like what's the best idea here. Like, do we go full on grid problem and model the grid in a better way? Maybe that is tempting. So we could have like actual tiles and see okay, this tile has a star, then we look at its neighbors, and this tile would say, okay, I am a number, and the actual number is 467. So it could, collect the numbers around its cells or its tiles, and keep like a unique set of those. And if it's, the length of the set is 2, then it's a gear, and so on. Like, that could be a more straightforward way of doing things. I mean, no, not straightforward, but an easier way. Once you do the parsing, then the calculations become easier, I guess. It could be a way. We could also have a collection of all the numbers. So I'm wondering, if we have some sort of information about all the numbers and all the positions that correspond to, we could have like an iterator that gives you back all the numbers, all of these things, or I guess all the number slices, and then we can use that to solve part 1, because it will be like the nested loop, and we would have up to this thing, the num slices, which, by the way, I didn't understand why can't we inline this here. Oh, I guess because this doesn't have a type. If we put a type into this, it will know. No, it doesn't. Okay, so it's weird. I don't really understand why this is, but we can inline this. Oh, and it needs the stupid parentheses, right? Because otherwise, okay. Well, we can keep it like that. So following that idea, if we could know which are all the numbers and where they are, then we could iterate the grid also to find all the gear symbols, and ask, which numbers you are touching. That could be some idea, I guess. I don't know if that's much better though. I mean, I'm trying to think in the abstract of those two approaches. Like, one approach would be to model the grid in a better way. So each tile would be like an enum of being like empty, like symbol, and a number. And a number would be not just a digit, but this would be a cell that has the number 35, and this would be another cell that has the number 35. We could do that in the beginning, parsing that, and then do parts like 1 and 2 with that grid. That's one idea. But I mean, if we go with that, I think part 1 doesn't become all that much simpler, because we also need to like find the end of the number. Yes. And the other idea is to have a like a first iterator that gives you back the whole numbers, like finds each number and gives you back that, and the start of the number, or maybe like all the positions of that number. And if we do that, then I think that can be used pretty directly for part 1 and not so indirectly for part 2, I think. Yeah, maybe. Yeah, I want to try that, the second idea. So this neighbors function is it's quite horrible. We can think about, but it's working now, so let's leave it like it is. Okay, I'm not going to touch part 1. Let's actually add out of this a noisy thing. But I want to do something like a thing that returns all the numbers. Yeah. So we're gonna have a function, call it gets all numbers, and it's going to take the grid and it's going to do something kind of similar to what we did in part 1. So it's going to take the engine grid. Do we have type for that? Well, yes, it's this thing. So we can take it as slice, and it's going to return. I don't know if I can return like this thing that returns an impl iterator with all of that. I think I will just return a vector of the numbers. So the numbers are going to be the number itself and the coordinate, like the XY coordinates. So maybe we can have, we can have probably a type point, type alias for this. So it's going to return that and a point. Okay, and let's say let nums is going to be an empty vector, and we're just going to return this thing. And we're going to do something quite similar, right? We are going to go, maybe this add function wants to be, well, we can have a copy of that over here. We can think about better way of doing things after we have answer for part 2. So what are we going to do here? If it is an ASCII digit, we are going to measure its length, but we are not going to do this calculation. We are just going to do this, basically, num slice. Actually, yeah, we are not going to return the number. We are going to return the slice. Yes, the string of that number, because we are interested in its length. So we're going to have this num slice. We're still going to do this, and we're going to say nums push the num slice. And it's going to be immutable vector. And you don't like this because you probably, yes, you need lifetime annotation for this. So can we have something like, yeah, something like that. And what's your problem there? Oh, yes, we also need the xy. So this number starts at, yeah, this xy coordinate, I think. Right? Yes. Yeah. Let's say let all numbers. Not a very nice function name, but okay. Let's suppose that this thing is working, and we can actually test if it's working. Let's print line let's do a debug print the nums, passing this thing, and collect. Oh, this is already a vector, so we don't need to collect. Oh, not with the input. Let's do it with a sample. Nope, sample txt. This looks alright, yes. Okay. So we have all the numbers. Oh, and I'm ran out of mate. Okay, with this, we should be able to pretty easily make like a hash map of position into number. Yes, that's what I want to do. So let's say let's mute num positions, or numbers by xy, I guess. It's gonna be a hash map new, and we're gonna do for each number and xy in get all numbers, passing the engine grid. We're gonna do something. This we need to import, yes. You don't like this because you need a type annotation, yeah, but you can probably infer it when I use you. This, let's actually give it a proper name. So for each of these, this is a number, a number slice. Actually, do we need to do this? Maybe this thing could have like a vector of points, and you know, already do that, but yeah, let's just do for this would be the number x and number, no, well, the x2. What do I want to do? For x going from x up to x plus num length, because remember that this number is actually a string slice. We're going to do numbers by xy. Whoops. And we're going to insert the key is going to be x and y, and the value is going to be, well, it's a number slice, but it's fine, kind of fine, not exactly. I'm not super happy about this. Maybe we can have like begin, like start x, end x, and the y, something like that, because we do have this information. Yeah, and just work with actual numbers. Yeah, that seems better, and we won't need lifetime annotations and things like that. So screw it. Let's do that. Let's return the number. We are no longer going to return a point, I guess. We are returning 4 different U sizes, or 3 different U sizes. A beautiful, beautiful thing. We are going to return. So we're going to push. And now I'm going to start by y. Y, the starting x, and then x plus num length. Beautiful. Which is like the last x, I guess. Or maybe we can just return the number length and do calculations based on that. And instead of doing num slice, let's parse the number actually. So number, we know that this is a number, so it shouldn't fail. Let's use num slice, parse, and unwrap. So yeah, this, we're going to put the number here. Yeah. Okay. Great. And here, what we have is y start x, and now did we push the length? So it's the xy, and why did I say yx? Let's follow things. Xy and the length of the number. So this is xy and length of the number. Let's call it num length, why not? And we are going to go for x, starting at x and up to num length. And we are going to insert this, yes. Redundant parentheses, okay. So now we should have a hash map with all of the number positions and the numbers that correspond to that number position. Great. And now we can solve part 2, I think, quite in quite straightforward way with all of this mess. So we can say for each y and line in grid, engine grid, iterator, enumerate this thing. Right? Do we need a line actually? I don't know if we do actually. Oh yeah, let's keep it. And for each x and character in line, yeah, we can index by characters, right? I think so. Characters or bytes. What are we doing here? We are actually sort of treating all of these things as bytes. So let's be consistent and iterate over bytes. And this is what? No, bytes enumerate. Sure. And this thing is, well, a byte. So let's call it byte. And now, if the byte is a star, then we want to know its neighbors, and we are going to like collect the different numbers that are on those neighbors, right? I think so. So let's say let's neighbor numbers and we can use a hash set for this and say something like for each neighbor x and neighbor y in the neighbors of this xy thing, so the neighbors of this star, we can then do numbers by xy get, and we're going to pass the nx and y, and if this is some number, then we are going to push it in the neighboring numbers. Okay, so if let some number yeah, and this should take care of repeated numbers. I think so. I didn't check if in the actual input there are repeated numbers, because that would screw me over. That would really screw me over. But let's assume that there aren't. Like if a single gear has two neighboring numbers, and those are the same numbers, because that would screw me over. But okay, let's assume that that isn't the case. I think here it wants to receive a reference, sure, And if that's the case, then neighbor numbers, insert, and we are going to insert nx and y, right? And actually we're always using it as a point, so well, yeah, let's put nx and y. Why not? And you don't like this because you're not mutable, probably. Yeah. And now, okay. So after this, let's print star at x and y has numbers, and just debug print this set, so neighbor numbers. Let's run it with a sample. No, this is not what I want. Yeah, I'm putting the position of the neighbors, which looks fine, right? This has 3, this has 1, and this has 3. So this looks promising, but I don't want the positions here. I actually want the number. Okay, so let's go again. And yes, it does have 2. And let's run it with the actual input, where we have a bunch of 2 neighbors, and some are single numbers. Okay, I hope that there aren't repeated numbers. We can probably check with a script or something, but or actually we have the information to know with this get all numbers function that we have used. But let's now do, like, this is the answer for part 2, and what we want is what is the sum of all the gear ratios in your engine schematic. So let's say let's mute gear ratio sum is going to be 0, and here if the neighbor numbers length is 2, then gear ratio sum, we're going to add neighbor nums, iterate, and products. Yes, product. The product of these 2, and this wants a type. Sure. You don't like this? Why? Because the neighbor numbers are references. What? Cannot be multiplied. Yeah. This is a reference to a number. I guess we can put a number actually. Yeah. And if we do that, do we still need? Yes, you do still need this. Okay, and let's now print that. Print line gear ratio sum. And what's your problem? Yes, that I didn't close this. Okay, that's actually the actual input, but let's first check the sample. Is this correct? 835, yes. So let's run it with the actual input, and this big number, is this correct? Yes. Okay, great. That was actually quite some code. 122 lines for day 3. Ugly lines, and this can definitely be improved. And I really don't like how the automatic imports are done like by default. Like I would prefer to have 3 different lines for this, but this is, I don't know what VS Code does automatically. So okay, we do have to like a working solution, and I'm a bit tired already. I think I'm a bit foggy. So yeah, let's call it. Let's take a break, and yeah, I will take a break and follow this later with some usual refactorings to try to trim down the solution to something reasonable, because with this get all numbers function we should be able to reuse the same thing for part 1 and make part 1 like much simpler, and I think there's lots of things that can probably be improved, but I'm already a bit foggy on my mind, so I want to take a break and follow later. So that's it for this video. If you have been, thanks for watching and see you later. Bye bye. And